Firstly, we will have Mr. Prof. Aziz Merchant to be sharing about what Industry 4.0 is all about in the first 20 minutes. We'll then invite Mr. Sharael Taha, Vice President of Rolls-Royce, to talk about future roles and expectations of employees in Industries 4.0. Up next would be Mr. Faiz Selamat from Executive Director from Mendaki Sense to be sharing about training and upskilling opportunities. We'll then wrap up the session with a Q&A segment. Without further ado, let's now invite Mr. Sharael Taha to be sharing to start off the session. Mr. Sharael, please.
So a lot of interesting stuff. So what are we going to do this week? So next slide. So this week is going to be a collision course, as I mentioned earlier, with what we've learned about engineering as a career. That's going to come in. We're going to bring in the technologies that we would be looking at in the near future, that's already here and that will be prevalent in the future. And then this week, we wrap it up by supplementing it with what is happening in the landscape, the changing landscape, Industry 4.0. So as these three elements combine, and why I call it a collision is at the center of it, we look at the opportunity. So the opportunity for an engineer or the opportunity for those coming in the engineering field. And that's where Mr. Faiz will talk to us about the upskilling and the training opportunities that's available. All right, so we'll try to bring it all in this week so that you guys as the participants, you get to get a good feel of, or rather a holistic feel of the future of engineering and where engineering will lead us to as a career. Okay, so the panelists for today, we have the very much esteemed Professor Aziz Merchant, who is the Executive Director for Keppel Marine and Deepwater Technology. So Prof. Aziz, he is renowned, he is covered in many fields, right? He is a leading international ship and offshore designer, and he's an expert in his field. He obtained his Master of Science in Naval Architecture from University College of London and Bachelor's of Engineering in First Class in Naval Architecture and Ocean Engineering from University of Glasgow. He's also a graduate of the Global Management Program in Harvard Business School, and he has over 25 years extensive experience in the design and engineering world of offshore and oil and gas development. Right. So Prof. Aziz is currently the Executive Director of Keppel Marine and Deepwater Technology. He's also the adjunct professor at NUS since 2014. He has about 115 international scientific patents granted or filed under his name. And he has also won a lot of awards, including one of the awards for engineering a first world, being part of the winners of the Institute of Engineers Singapore, the competition engineering a first world 50 feats that transform Singapore's award in 2016. In addition to that, he's recognized in the industry for his unwavering drive for innovation. He received the Singapore Maritime Port Authority Outstanding Maritime R&D and Technology Award in 2008 and 2015. And he's also won the Institute of Engineers Singapore Prestigious Engineering Achievement Awards. He is a member of the Singapore President Technology Award Selection Committee and has served on many technical committees and boards. So I'd like to welcome Professor Aziz Merchant being one of the panel. Definitely fantastic to have you here. Then there is also Mr. Faiz Selamat, who is the Executive Director for Mendaki Sense. So Mr. Faiz Selamat has been with Mendaki Sense since 2017. He has more than 15 years of experience in organizational change, business development, and training system. Mr. Faiz has sought to refine and enhance what is Mendaki Sense value proposition, especially in the areas of employment, lifelong learning, and community development. So he took on the JUMP campaign, which is the Jobs, Upskill, Mobility, and Professional Development campaign. And he has led the team to launch the various efforts targeting at the different segments of the community. So it's fantastic to have Mr. Faiz with us also as part of the panelists. And again, for myself, Sharael Taha, I'm currently working on the next change project, which is adopting the next Industry 4.0. For me, I'm still an engineer at heart. Started my career working on race cars and race engines, and since then I've worked in oil and gas, shipbuilding, telco, consulting, and now I'm in the aerospace industry. And before my current role right now, I was based in UK, leading a global team of project management professionals deploying projects across UK, Germany, Canada, and Singapore. And the projects I do love doing is infrastructure projects like facility transformation for Industry 4.0. I've done quite a fair bit of new product introduction on the latest generation trend engines and capability acquisition in the aerospace industry on both the original equipment and the maintenance, repair, and overhaul industry. So definitely excited to have both Professor Aziz and Faiz, Mr. Faiz, to be with us today. And without much further ado, we'll let the man speak about Industry 4.0 for himself. All right, Prof. Aziz, can you take away? Thank you, Prof.
Can you all see the slides?
Yes,
okay,
we can.
So I'll begin the presentation. Thank you, Sharael, for the introduction. Assalamu alaikum, and a very good afternoon to all of you. Okay, so before I go into deep dive into Industry 4.0, basically just to give a bit of overview on the presentation format, I'll just give you a very short introduction, just to introduce which part of Keppel do I come from. Okay. So as what Sharael has mentioned, I come from Keppel Marine and Deepwater Technology. It's basically the offshore and marine arm of Keppel Group. And the company has been in existence for the last 50 years. And we have basically designed and delivered more than 100 vessels in the past 25 years. And in fact, the first ice-class vessel was designed in Singapore for operation in 2007. So this, I mean, we coming from the tropical countries, not knowing enough about ice, were able to deliver 2 ice-class vessels for Russian waters. So these are some of the products that we have manufactured in Singapore. And many of you may not know, but all of these projects, more than 100 of these projects, were basically conceptualized, designed, and manufactured in Singapore by Singaporean engineers. And this is something to be very proud of for a small country like us, basically, that we are able to innovate and basically be a key drivers in the offshore and maritime industry. Now, this is a photo of one of the products that we had delivered. This is basically a flotel, and in short, it's called a floating hotel. In fact, if you drive through Tanjung Pagar, you will be able to see it. And currently is housing close to about 600 migrant workers. Okay, these are, and the vessel was basically operating in Australia. And when there was a call for them to come down to Singapore, they came down to Singapore and we did some modification to suit the requirement for the migrant workers. And currently is basically housing more than 600 workers. Now, as there's disruption in many industry, there's also disruption in the maritime industry, especially in the offshore industry, where oil and gas prices have come down, where oil was, in fact, for the first time in the last 200 years, was minus $37 a barrel. So that means that we got to repurpose ourselves. We got to repurpose our technology for Smart City 4.0. And as engineers, we need to be adaptable. We cannot say that we have been doing this for the last 20 years. We will continue to do it for the next 20 years. So as engineers, agility, adaptability is very, very important. And so what we have been doing for the last 4 years, starting 2016, we have started to repurpose some of our maritime technology for other users, like a floating city urban development, desalination plants basically. And you may ask, why desalination plant? Because in desalination, it creates a lot of heat, and you need to take this heat away from the plant. And the best way is that if you have a plant sitting in a reservoir of water, the water is basically used to cool the plant. So it basically brings the energy requirements down and then is able to provide a better solution for desalination on shore plants basically. So we're also looking at Anchorage Hub sustainable solution. As you know that we are a bit, in terms of land, we're also a bit less, but in terms of water surface or sea space, we're also limited. So what we're trying to do now is that if we want to basically move into floating city desalination plant at the Anchorage, we have to find for these ships. And one way is basically to anchor them in terms of hub, rather than taking vessels that have to be around 600, about 200 meters, because usually when you anchor a vessel, you need to basically take this entire radius of 400 meters. So 2 times to the diameter or the length of the vessel. So by you can keep it in the hub, you try to basically make your sea space a bit much more productive. So these are some of the concepts that we're looking at. And the next concept we're looking at is Aquaculture Hub. Basically, is a floating fish farm that we're also looking at. This is part of this 30 by 30 Singapore strategy. So what's Industry 4.0? It's basically a change in the way products are being produced, delivered, and consumed. Okay, in a very short form of it, basically. And you can see that in terms of industrial revolution over the last 4 revolutions, basically, you can know that in the Industry 1.0 is basically transiting from hand production methods to machine production through use of steam power. So the Industry 1.0 was all about steam-powered machine. Then slowly we moved to electric-powered machine, where we basically were introducing mass production. And then Industry 3.0 is all about autonomous production, automation, trying to marry machines with IT and automation basically. And that was basically where we moved to autonomous machine. Now we are moving to smart machine, where the machine, we basically fix them with sensors so that if a machine is in poor health, it's able to tell the user, and then we can basically take timely actions on it. Okay? And this is because of IoT, cloud computing, advancement in human-machine interface. Now, if you look from a business sector and arena, every business and industry today has been disrupted, okay, due to Industry 4.0. Whether you talk about security, transaction, interface, decision-making, mobility, or even factories, basically. So today, you look in terms of transaction. Today, we are using more and more IT-based or virtual currencies rather than cash. Okay, when we use our Grab app or when we use our Uber app, we tend to do a lot of machine transaction. Okay. So I think so, time have changed. And you can see that when we moved from Industry 1.0 to 4.0, it took us about 200 years. But when you're moving from Industry 4.0 to Industry 5.0, it will be a very shorter time frame. And today, people are always talking about Industry 5.0. So you can see the speed, the way technology is making us move into the next arena of Industry 5.0. Now, this slide basically tells you what are the technology trends. Okay, basically it starts with mobile internet. We know enough about renewable energy, energy storage. This is very, very important, energy storage. In fact, there's a lot of studies today being done on energy storage, pilot projects, and this is basically the holy grail. I mean, if we can be able to find a very good solution about energy storage, we can basically bring energy storage and renewable energy together. Because you know that in renewable energy, the issue is that you can only use the renewable energy at that point in time. Okay, but you're not able to store it. But if you can find the right way of a storage, like batteries are there, but batteries also have their limitation. Okay. Then we look at advanced material, 3D printing. In fact, there was presentation for the last 2 weeks on 3D printing. We're looking at next generation genomics, okay, autonomous vehicles, advanced robotics, cloud technology, Internet of Things. So these are basically 12 kind of technology that are the drivers basically that we are moving into Industry 4.0, and these are basically also disrupting industries today. So why it matters? Because we got to reset the playing field. Companies that were in the Dow Jones 10, the best 10 Dow Jones company, like Coca-Cola, Exxon, you cannot find them there anymore. The technology companies have taken them over, like Apple, okay, Amazon. So we basically got to embrace and be adaptable and be agile enough to basically understand what are this technology and how it will basically affect our business and our way of learning. And basically this impacts on economic, political, and society. So you look in terms of economics, expansion of trades, increased standards of living, massive employment, and also unemployment in some areas. But this way we have to be smart enough how to make this challenge to be advantage to us. Okay. In terms of politics, you see between China and USA, okay, because, well, China is basically moving a bit fast in terms of technology. In some areas, US is a bit behind, especially in terms of 5G technology, and you can see that the difference that is happening, or the war, the economic war is happening between US and China. And with regards to society, some cities are growing, there's increased population, and at the same time, increased innovation. So basically, digital economy has given rise to new business model. So you look at Uber. Uber has no taxi, but it's one of the biggest taxi company in the world. Okay, same thing for Skype, Alibaba, Facebook, Google. So these are companies that you never heard of 10 years ago. But today, these companies you keep hearing every day, whether in newspaper or over the social media. You don't hear of Exxon as regular unless there's a drop in oil prices. So the traditional career models may soon be a thing of the past. And with our growing population, which we are predicting 6.9 by 2030, and also our aging population, where the median age of Singaporeans will be close to 50 by 2030, we basically got to embrace technology as part of our normal working life, basically. And one thing to note is that when you work for a company, I would say at my time, during my time, or even people who have worked before me, they used to join one company and they had only one career. What does that mean? That means that if a person joins a company, he most probably retire from that company. So when he starts at the age of 21, he most probably retire at the age of 60 from that one particular company. But in today's world, that may not happen. Companies that are today existing may not exist in 20 or 30 years down the road, because things are happening, changing too fast. And if the companies do not change with them or change with time, they will be dinosaurs. So as an individual, as engineers, we also need to be agile enough to know what is the next technology that's going to happen in the next 5 to 10 years and start learning about it today rather than at that point in time. So what is the future of jobs? So these are jobs under threats: travel agent, tellers, legal assistant, journalists, finance assistants. These are jobs of the past, or maybe they are there today, but in the next 5 years, they may no longer be there. And these were jobs that did not exist 10 years ago, like data scientist, drone operator, apps developer. Especially you look in data scientists today, I know Singapore is having a very difficult time in trying to find people with data scientist expertise. So with the changing nature of work, we are moving away from repeatable task-based jobs to problem solving. So we are moving more to value-added jobs rather than task-based or predictable. And there has been some survey by Mercer that 40% of the job that we do today can be changed or can be automated, basically. But there are also studies, but at the same time, they do also say that 10% of these jobs are threatened. But whether this is true, we really don't know. We only know within the next 10 to 15 years. So my message to all of you all is that we start to look into jobs that must create more value for your employer, okay? And it should be more expertise driven, and it should be more on skills development. So what will we see, this technology trend will result in companies moving their manufacturing facilities from countries with cheap labor to countries that have high skilled workforce. And if we take the example of Luxembourg, where near 60% of their entire workforce is employed in jobs demanding high level of education and skill. And I think that this is where we should be moving into. This is where Singapore should be moving into. Because what it means that if you have a highly skilled workforce, more of the technology companies will come and invest in Singapore. That means that we will get good paying jobs and our GDP will go higher. And that should be our aim be. And for us to do it, we need engineers, we need more engineers, and we need our engineers to keep learning. Learning shouldn't stop as when you graduate from your university, okay? In the past, that may have been the mindset that once I leave university, I stop learning. But in today's world, you never stop learning, basically. Even at this age now, I'm learning about business intelligence, I'm learning about AI, I'm doing advanced in Python programming so that I could better understand what is artificial intelligence. So I give an example how business models are changing. So previously, we used to sell product. Whenever we had a manufacturing plant, we'll sell products. And that was the end of our relationship between us and the customer. From time to time, he may have come to us saying, okay, if he needs some spare parts, okay, you have that kind of business. But today, companies are moving to product as a service. So what does that mean? That means that if today I'm an airline company, I purchase a desired result based on equipment performance rather than equipment that may deliver the results. So in short, what I'm doing is that, so you take Rolls-Royce for example. Sharael will cover this more in his presentation, but what Rolls-Royce and other engine manufacturers are doing is that they are not selling you the engine, but they are selling you the engine hours, or what we say, selling trust. As long as the engine operates, they get paid. So that means from the airline company, the capital is reduced, but at the same time, the engine manufacturer get recurring income rather than to have a lumpy income on a quarter-to-quarter basis. And this is possible because we are able to do cloud, we have sensors and we have cloud computing and we're able to do data analytics. And this basically tells us that when is this engine going to break down? And before it breaks down, we do the maintenance so that the engine doesn't break down. And that is a value to the airline company. Now, what does it mean and how are we responding? Now, in Singapore, we know our drivers in shaping our future is increase in population, economic activities, we have a constraint in manpower and land and sea space. So if I take the maritime industry as a key enabler, okay, which basically contribute to 7% of our GDP. So you can see that the maritime industry is a very important industry for Singapore. Okay? We are the first three, we are one of the three top ports in Singapore. And for us to remain top, we need to embrace digital technology in our day-to-day working basically. So the maritime industry, as all the other industries, are also facing competitive pressure. So you can see that the way we have moved up, previously our ports were all in the central part of Singapore, but we have moved the complete operation now into Tuas. And the whole objective is that once you are in Tuas, you can basically operate all under one big umbrella. So there is a industry transformation map for the maritime industry. And what we intend to do, what the whole idea is basically to create 5,000 good jobs in the next 4 to 5 years. And this will basically increase our GDP by another 4.5 billion basically. And we are looking at many centers of excellence in this ITM, and digital is one of the key enablers for this to be successful. And I'll give you one example. What are we really doing? So you have heard about autonomous vehicle, autonomous cars on road, but there is an autonomous shipping project in Singapore. And we are basically moving into autonomous shipping by 2025. And this is one of the examples of a tugboat. As you know, in Singapore waters, at one point in time, there are about 80 to 90 tugboats. And the objective of a tugboat is that whenever a ship comes into port or the anchorage, you need a tugboat to pull it to the port facilities. And usually on a tugboat, you have close to about 12 people on board the vessel. But with the seamen who are operating the tugboat, most of them are foreigners. Most of them come from Indonesia. Singaporeans don't like to work on a tugboat or be the master of a tugboats. So how do we make this job for Singaporeans? So what we are trying to do now is that we are trying to make this tugboat autonomous so that it can move from point A to point B on its own. It can also do the tug operations autonomous, but the operation will be onshore. And you can see in the slide, the future command center. So that's how the command center will look like. So it means that we'll have cameras, leader, everything on the vessel. And an operator can basically operate 2 or 3 vessels under him basically, or under her. So these are what we're trying to do, trying to basically create jobs for Singaporeans. And the other thing about tugboats is that usually tugboats, sometimes there's a lot of waiting time. You have to wait for ships because sometimes the ships can be delayed. And so sometimes you can go to your point where you're supposed to meet the vessel, but the vessel is not there. So sometimes there's a waiting time for 4 and 5 hours. So that doesn't help you in terms of productivity. So the whole objective here is basically trying to create new jobs for Singaporeans. So we hope by 2030, this is how our Tuas port landscape would be, that all of us will be digitally connected. Okay. But you can see that in my presentation, I've used the word digital, but I don't say that people only with IT have a stake in the future. I'm not saying that. Engineer has the biggest stake. Because what I have found as a practical practitioner is that many times when I want to do autonomous vessel imaging, data analytics, if I pass this problem to a data scientist without the domain knowledge, he will not be able to deliver what I want. So engineers coupled with data analytics skill, this is what the industry is looking for. So whatever your domain you come from, but if you have some data analytic skill in artificial intelligence or in BI, that will help you a lot for the next generation of jobs. So are we ready? So here you can see that we can never predict the future, but the external drivers of change can help us point the way. So you can look at oil prices today. They are very volatile, but at the same time, in terms of climate change, it's not helping us. So there's a lot of push to move to carbon-free technology. So these are where, as engineers, we should be looking at technology where we can basically move into renewable energy. There's digitalization, artificial intelligence, trade in sustainable urbanization. I gave you a few examples of floating city. And the opening of the Northern Sea route, you can see that most of the trade is happening through the Straits of Malacca, but the Northern Sea route is also opening up. So if that opens up, our maritime sector can also, in future, may have some issues there, or may have some challenges there. The next one is about climate change. Today, we don't feel so much about climate change in terms of carbon taxes. Today, for every ton of carbon that we emit from our industry, we only get $5. We get penalized, or there's a tax of $5 a ton. But in other countries, like the countries in Scandinavia, they get basically charged $80 to $90 a ton. So that means that in future, if you get higher taxes, you need to find your businesses to basically emit less carbon. So you need to find new technologies where we can basically help the industry. So from a Singapore perspective, are we positioned? We are basically among 25 leaders in advanced manufacturing. Okay. In fact, if you look from AM, in fact, we started AM in 2010. At that point in time, we had the AM facilities in NTU. And at that point in time, we were only printing plastics. But today, we are printing high tensile steel using AM at NTU basically. So that over the last 10 years, we have moved from plastic to printing steel. So Industry 4.0 looks at intelligent machine, but we still need high-skilled talent to work at the factory floor, and that's where we work with the robots. So you need between the interface between human and robots. And in our school, we have a lot of focus on STEMs subjects. And the only thing, my advice to all students who are there, please do physics as a subject, because physics is very, very important if you want to be a very good engineer. And what the government is also doing, National Research Foundation, is that it's basically trying to marry academia with the industry. And they have corporate labs. So in the past, academia used to do research basically in the field of science. And once their research is done, they just leave it on the shelf, and that was the end to it. They wrote a few journals or a few papers to it. But today, NRF feels that that's not enough. We need to basically bring a lot of this science, translate into technology, into commercialization. So they have basically married many of the MNCs in Singapore to work with the academia. And we also have to build local skill sets in artificial intelligence. And there are many, many initiatives in AI through AI.sg. Okay? And I would basically encourage you all in fact, after this talk, go to AI.sg website, and there are many programs there more in beginners basically, where you can basically try to understand more about this technology. And that is basically my last slide. With that, thank you. Sharael, up to you now.
All right, thank you. Thanks a lot, Prof. Aziz, for sharing with us your presentation. So a few things I do note down there. One is please do physics. It's my favorite subject. We got that sorted. All right, make sure that everyone does physics also. All right. People in IT, sorry, you were saying that data scientists without domain knowledge makes it very difficult to execute something. I completely agree with you also. And it's engineers with the data analytics skills are very much needed in this new industry. I'm with you on that. So in fact, as we try to roll out the executable projects that actually bring commercialization value, you see more and more the value of engineers with data analytics skill. In fact, I've had a few chats with fresh graduates, fresh engineering graduates. They're saying, should I be doing the really raw programming and move purely into data analytics, to which my advice to them is always focus also on your engineering side, because not everyone can just be an engineer, but an engineer with data analytics skill is definitely much sought after. Well, thanks a lot, Prof. Aziz, for sharing your session. And then we'll have a chat with you during the Q&A again. Lots of questions. I see lots of questions in the Q&A posted to you. So just be prepared, yeah? All right. So next up is my segment. Let me just share this with you first. Share computer sound. Okay. If you can't hear the sound, do tell me, yeah?
The Rolls-Royce jet engine, the pinnacle of engineering excellence. As pioneers of power, we are entering a new era, one where our engines and innovative care services are supercharged by advancements from the digital world. This is the era of the intelligent engine. The intelligent engine is connected with other engines, with its support ecosystem, with its airline, allowing us to sense and respond to changes in the operating environment. It's contextually aware. Big data means that it's aware of its current operating context and the requirements of its airline, offering advice to minimize fuel burn and operational risk. It's self-aware. It knows when it needs maintenance, and in the future, thanks to advanced robotics and artificial intelligence, may even be able to perform that maintenance itself, without any human interaction. And it learns. Through machine learning, it learns from its experiences and those of other engines in the fleet, identifying and fixing issues long before they have any impact on an airline's operation. All part of achieving our vision of ensuring every Rolls-Royce powered aircraft takes off and lands on time, every time, with maximum efficiency.
All right.
Volcanoes are pretty impressive things, naturally occurring events. And most people have seen some big dramatic pictures on the news.
Sorry. Just give me a second while I go back to my slides. Are you guys seeing my slides now?
Yes, we do see your slide.
Okay, all right. Okay, so that was just a quick sharing on the concept of the intelligent engine. As you see in that video, we talked about engine talking to engine, engine talking to a base station, and it's all about the interconnectivity of everything right now. So as Prof. Aziz was sharing, so Industry 4.0 is about the interconnectivity of the cyber physical realm. So beyond the technical space, what does it mean for us as engineers? What does it mean for us in terms of changing our mindset? How do we approach this new norm? All right. So let me just take you to the word revolution itself. We talked about industrial revolution. Industry 4.0 is the fourth industrial revolution. So what does it actually mean? So if you look at revolution itself, it's about a dramatic and wide-reaching change in conditions, attitude, or operation. Right? It's about driving that dramatic change. It's not. This is not to be seen as just an incremental improvement, but we're looking at a revolution, a step change in how we do things. So with this Industry 4.0 right in front of us, should we be expecting anything less than a radical change? Should we be coming to this as just any other day and just a continuous improvement? All right. So if we look at the four industrial revolutions, as Prof. Aziz walked us through this, yeah. The first industrial revolution is about steam power and mechanization. So it brought the farmers out from the fields into large cities and grew those cities. In the second revolution, with industrial revolution, we talk about not only is the factories now mechanized and there's steam power, we now have mass production line. We have assembly lines. We have the Henry T model Ford. Yeah. And the third industrial revolution, which was in the 70s, was when the use of computer and automation and robots start coming into the automotive industry. That changed jobs, that changed skill sets, that changed how we interact within an organization also. And this fourth industrial revolution, we talked about, we say that this is the interconnectivity of the cyber-physical realms, right? So what are the common themes from this past industrial revolution? Number one, that was very clear that new skill set was required. Between the first and the second, we talk about having more production lines, from no steam power to having mechanization and steam power equipment. We talk about the farmers having to be able to pick up basic mechanical skills. In the third revolution, we talked about simple mechanical skills then become coding for robots. So new skill set is required. There's different ways of doing things. There's role changes. There's a new quality engineer, a production engineer. We look at mass production assembly line. We always talk about lean, right? Lean, where we start having an industrial engineer. What is the cycle time? What is the tech time? And we talk about organizational change. Not only about organizational change, but societal change. The move of farmers into cities, into larger cities, into digitized cities. So these are all the themes that we should be expecting from industrial revolution. So should the changes be any less than what we experienced in previous revolutions? Should we be expecting the fourth industrial revolution to be as huge a change as the past industrial revolutions were? And how do we get prepared for this? So what is different with this next revolution? So as Prof. Aziz shared just now, there's a lot of new developments that's coming on board quickly, rapidly, and more importantly, getting connected to one another. From the mobile internet to renewable energies, through energy storage of batteries, to advanced material, 3D printing, oil and gas, and all the good stuff there, coupled with the Internet of Things. By itself, this technology, for example, a mobile internet, would only serve a particular purpose, but then now you connect mobile internet with the Internet of Things, being able to connect any sensors on an IoT platform, connecting to the cloud technology, which means you don't have in-premises servers, together with 3D printing that could allow you to print in any other part of the world. You could be a engineer designing the part in Singapore, but you could be printing the part in Germany. So you see, what is completely different about this revolution is all these different technologies are coming on board and connecting to one another. It is about this interconnectivity that scales up and makes this industrial revolution huge, and a big elephant to chew on. All right. So let's look a bit more about this concept of interconnected cyber-physical systems. So Prof. Aziz just now shared about the product as a service business model is now being challenged. And in fact, for Rolls-Royce, Rolls-Royce gets paid based on the hour of thrust it delivers. Right. So at every engine burn hour it produces, and every thrust hour it produces, that's where it gets paid. It doesn't get paid by the engine itself. Right? So what does that mean? That means that maintenance is then managed by Rolls-Royce, or maintenance is managed by the OE manufacturers. This has become the norm now. And it becomes very important for the OE manufacturers to then be able to predict and to understand life cycle costs. When an engine needs to be pulled and repaired, when an engine needs to be maintained, and when an engine is to be repaired and serviced before it fails. So all this then becomes part of the OE manufacturer's concerns. Right? So if you look at how do we develop the supply chain mechanism in order to make this happen. Let's start off with this graph. In an OE manufacturer, you get your raw materials. For example, for the fan blades, you have raw materials from, you have titanium as raw material. The titanium will have the data on what is this material, its tensile strength, which batch is it, where is it from. The raw materials is then put through a manufacturing process. So there'll be a lot of manufacturing process with lots of different parameters that as a manufacturing facility, it will keep all this data as its production control process and do its statistical process control, SPC chart, to show that this is what it's doing. This is, by controlling this process, you control the output. Once you manufacture it, then it goes into the assembly plant. So for those engineers out there, you may be aware of this engineering term called tolerance stacking. So when you manufacture or you build a particular product, it cannot be perfectly 5.35 millimeter, for example. It will be 5.35 plus minus a certain amount. And as you put 18,000 parts together, there is a tolerance stacking in there. So that then becomes the attribute of the product that you are assembling. Once you assemble the product, it goes through a series of tests. As our first and second week speaker, Dr. Aris Hid was sharing, how do you diagnose tests and how do you investigate issues on tests, right? When an engine passes tests, it then goes into the wing of the aircraft. That's where you have flight operations. It's supposed to climb at this particular rate. The engine is performing at this particular temperature. This is exhaust gas temperature. This is how long it's operating for. And at the same time, you also have the engine talking to the rest of the environment. What is the operating condition? So if you have an Airbus A380 taking off in Dubai, for example, in very sandy environment where there's a lot of silica, and the sand is ingested by the engine, that creates erosion within the engine itself. And then it moves on to real-time monitoring. As the engine is flying, you are monitoring the engine parameters, its health, and also its performance, which then leads into the time that's required for it to be brought back to base, to be maintained, repaired, and overhauled. So this is the whole entire product life cycle, albeit in a very simplified version of how an engine goes from soil, from the mine, to being manufactured, to flight ops, and to getting data, and to being repaired. And that green circle is in a continuous loop with an engine life cycle about 30 years. Yeah, but at every point in time, there'll be engineers collecting data. There'll be engineers collecting data at manufacturing portion, collecting data on the manufacturing process, the assembly process, the test process, and the flight ops process. What is happening in this interconnected cyber-physical system is that the data are no longer being looked at in silos. In the past, we as an engineer, we're only concerned with the data that's belonging to our particular portion. For example, if we're an assembly engineer, we're only concerned about a particular measurement when we assemble the engine. But as it goes on, you realize that the data, the digital thread, is important in order to predict the performance of an engine. So we're moving towards a stage where if you know the raw material, you know the manufacturing data, you know the assembly data, you know how it's being tested on, and we know that, for example, an aircraft, the engine is placed on an aircraft like Scoot that flies short haul 4-6 hours and is traveling in high sulfuric content. By knowing the product attribute, you should be able to predict within the next X number of cycles, you've got to tear the engine apart and do maintenance for it. So you can see that where we as an engineer thought that data is in silo is now being part of a bigger relationship of data, a bigger network of data to be able to drive better decisions. In the past, we see data as only X and Ys. now in this digital thread, in this connected streams, as an engineer, we're looking at how the data is interconnected with one another and the network of relationships of data. So with that being said, one of the critical changing mindset that an engineer faces as he moves to Industry 4.0 is about how do we drive that value stream thinking? How do we move from thinking just beyond our cell inside a facility into the wider value stream? How it contributes to the wider value stream. There's a lot of conversation on this democratization of data, which is data no longer has any barriers. It all comes in and everyone has access to the data. As an engineer in a production line, you'll be pretty much worried about it. Who owns this data? For example, if I was a process engineer and now my boss and even my boss's boss is able to see the performance of my process, the first thing I will do is to fear that, oh, I don't want to share this data. All right, this is proprietary. This data will be used against me or would be used to mark me down in terms of performance. But with Industry 4.0, this is exactly what we need to overcome. We need to stop thinking in silos. Think about collaboration. Think about the likes of Uber and Airbnb who don't own those assets but start collaborating with one another. And how do you bridge the digital divide? So as an engineer in the Industry 4.0 or looking forward to Industry 4.0, your soft skills will be as important as your technical skills. Right? As you work towards collaboration, as you work towards building a new business model and adding the digital element for digital transformation, your soft skills of being able to get the data from people or to be able to work collaborative together, to string together the data in that value stream becomes exceptionally important in order for you to drive that actionable insights, which leads to the next thing in terms of changing mindset. Yeah, we as engineers, people in the engineering field knows that, and in fact, in every CV that we write, we say we are very analytical, data-driven. So just a few quotes here. Not everything that counts can be counted, and not everything that be counted counts. And if you can't measure it, you can't improve it. That was how I started my career actually, in race cars and race engines. As we look at race engines, we're always looking at the data for race engines, how it performs, what temperature it's at, what is the engine coolant temperature, and what is the corresponding horsepower to it. And we make some tweaks, and then we look again at the data. So I truly believe in, if you can't measure it, you can't improve it. But on the flip side of things, now with Industry 4.0, interconnectivity, there's a lot of data coming in. You look at the top left-hand corner, the comic down there. See, I told you that big data was too scary. Big data scares a lot of people, right? And then the rate of confusion, or rather, the level of confusion increases with the more data that you have, right? If you look at what to expect from a factory in the new Industry 4.0, we have the innovation department working with mobile tablets and mobile PCs, and all the guys on the shop floor is keying in information into the system, right? We know where the guys are walking, we know how long the guys is working to do particular stuff. Engineers are connected to machines, machines are connected to other machines. We are doing rapid planning. There's information how to optimize the assets. There is cyber safety, cyber security assets on the ground to make sure that it's being safe. The threat warnings, the robots are talking to one another. So in a connected factory, there's a lot of data that's going in and out. If you also look at the future of MRO, the future of the aerospace industry, you will have things like RFID for inventory, you have record keeping, you have handheld devices, you have augmented reality, 3D printing, advanced warehouse management using ASRS, advanced storage retrieval systems. You'll have a predictive maintenance. So what I'm driving at is there'll be a lot of data coming to you as an engineer. We will, as engineers of the future, we will never be short of any data. 20 to 25 years ago, data was only collected through spreadsheets. 3 to 5 years ago, data is collected through isolated systems like Facebook, like your PC, the server, the on-prem server, and what have you not. With Industry 4.0, we're heading into where the data is all starting to be dumped into a data lake. There'll be enormous amount of data for you to get at, to understand the current situation. So what is important there? The second thing that I've raised up here is for us to understand that a data is only good if it drives actionable insights, right? Very often, you'll have gigabytes of data. We will be drawn into looking at trying to get as much IoT devices and spending as much capital to embark on Industry 4.0. But very often, it's about the 3 or 4 critical data points that will drive the actionable insights. So as you are an engineer going into Industry 4.0, as much as it is interesting to be looking at what are the different ways in which you can pull data, it is also as equally important for you as an engineer, and to Prof. Aziz's point just now, as the domain expert, being able to interpret that into actionable insights. And beware from being overwhelmed by data. Yeah. And last, I just want to share with you this last one. How do I change it? The last thing everyone should be aware of as an engineer .
Talk a lot about leadership and how to make a movement. So let's watch a movement happen, start to finish, in under 3 minutes and dissect some lessons from it. First, of course, you know, a leader needs the guts to stand out and be ridiculed. But what he's doing is so easy to follow. So here's his first follower with a crucial role. He's going to show everyone else how to follow. Now notice that the leader embraces him as an equal. So now it's not about the leader anymore, it's about them, plural. Now there he is calling to his friends. Now if you notice that the first follower is actually an underestimated form of leadership in itself. It takes guts to stand out like that. The first follower is what transforms a lone nut into a leader. And here comes a second follower. Now it's not a lone nut, it's not 2 nuts, 3 is a crowd, and a crowd is news. So a movement must be public. It's important to show not just the leader, but the followers, because you find that new followers emulate the followers, not the leader. Now here come 2 more people, and immediately after, 3 more people. Now we've got momentum. This is the tipping point. Now we've got a movement. So notice that as more people
So the last but not least, I wanted to share with you guys is, the first thing, adopt the value stream thinking, look at the whole entire value stream, go beyond just the confines of your department or your function. Number 2, drive that actionable insights, look beyond the data, what is the data telling us? And the third one, take the lead. Don't be afraid to be the lone nut. This is Industry 4.0 is new, is nascent. Everyone is trying to grapple it, but be bold. take the lead, rethink the processes. There'll be new roles and redesign roles, and get out of our comfort zone. So my advice to you engineers, or us engineers, as we embark on this new exciting journey, be bold, take the lead. And with that, I'd like to end my presentation and hand it over to Mr. Faiz on the opportunities for training and upskilling in preparation for Industry 4.0. So Mr. Faiz, the mic is yours. Thank you.
Thank you, Sharael. Okay, hi. Let me just get my screen. Okay, hello everyone. Okay, it's been a while, so just going to bring through quickly. I have a presentation for the training side, but I was trying to build up on what has been shared earlier by Aziz Merchant as well as by Sharael. Just sharing another perspective of things. We talk about Industry Revolution 4.0. But there is something called Society 5.0. And this is something which was brought forth by the Japanese government, actually. So you can actually Google this out. This is not part of my main deck. I just Googled it during the presentation just now. So it's a beautiful way of looking at what Industry Revolution does to us. They look at the road to Society 5.0, where we talked about Industry Revolution 1.0, 2.0. They talked about society from we started 1.0 as a hunter-gatherer society to an agrarian society, followed by industrial society, and then information society. So it's very interesting. So after information, what is it? No, we are very familiar with the World Wide Web and the phones and everything. So what's next stage? What does Society 5.0 mean? As I said, it's going to be a quick one. So it's about how we integrate, how does society evolve with technology being a bigger part of our lives. And Sharael talked a bit about the IoT and then how work has changed, and they gave some examples. This is from Abenomics, so it's from the Prime Minister of Japan. So this is how they saw that how Japan has advantages for Society 5.0. And I thought that there's a lot of things which are relevant to the engineering field. You talk about technology, accumulation of data. There's a lot of engineering aspects to it that come together. And you also look at basically how it changes the world beyond just manufacturing, but also in terms of healthcare, in terms of the solutions that we have. So actually, I would say very rightly so, as what I said earlier, engineers are going to be increasingly more important. But the key part is how do you bring together all the different parts of from the data lake? How do you bring in the right insights? Because we know data is huge, big data. People got excited about it, but you know, my friends who do research, they say rubbish in, rubbish out. So basically, when you have so much data, you don't know what to do with it. So I think there'll be a very interesting yet challenging time for engineers going ahead. So just to share with you, I think you guys can just Google it out, what Society 5.0 is about. This is just a quick show in terms of how they are looking at Society 5.0 and how it actually changes the way we work. And as I said, there's going to be a lot of ways for us to see how in the engineering field, how you will change when you talk about sensors and AI, and how now you can see it's no longer about measuring, but it's all about the sensors and how you use the data to improve the way you make decisions. So yeah, so that's just a spiel on Society 5.0. For your info, since we are working on a new set of courses that looks into Society 5.0, because we think that's the next thing. You talk about industrial revolution, yes, technology is here, but the key part is we are looking at humans. And so how must humans evolve? How must society evolve to embrace this new change? All right, so now to the actual presentation. Okay, yeah. So hello everyone again. Okay, so this is on what I'm sharing today on the intern, upskill and work. Because I think for the past few sessions, we've seen that there's all the specialists, all the technical people in terms of what is happening in the field of engineering, what's the changes, the opportunities that's coming about. So I'm not an engineer per se. I love data because that's something that I do at the side. But I'm just a purely business arts type of guy. So so I will focus on the human aspect of things. All right. Okay, let me get this thing going. full view. Okay. All right. So so basically, I'm looking at three options. I know that the demography, the group of people that's coming in, there are some of you who are still studying, some of you just graduated, some of you are already working. So I look at it from three options. Now with this current situation with COVID-19 and so on, what are the options available to you? So I just want to share with you what's available. So for intern, I think you've heard of SG United Traineeships, and for upskilling, there's a work study diploma, certs, and also how you get work experience. So I'll be going through it in detail subsequently. All right. So SG United Traineeships Program. So for those of you who are going to graduate or just graduated last year and so on, right? This is a great opportunity that will be open as of 1st of June this year. But if you look at it this way, to do traineeships, they are giving quite a fair amount of allowances. And actually, all these jobs will be published as of 1st of June on the Careers Future portal. So for those of you who have yet to visit My Careers Future, my suggestion is please go now, okay, or get your friends to go now, because as usual, no, by the time it opens, there'll be a huge, everyone goes there, there'll be traffic jam, the platform will crash and so on. So get in now, set up your account, because when you need to set up account, you also need to fill in a brief background on you, maybe even your resume. So once it's up, you can start applying, because if I'm not wrong, yes, they are coming out with a few thousand places, but every year number of graduates is a lot more than that. So please be there quickly and apply now. I cannot emphasize that as much, that please go in and My Careers Future portal and then get your account set up, so that once it's 1st of June, you just immediately apply and don't get stuck in the traffic jam. All right. Okay. So this is the thing. So basically, what's happening is it's traineeships across various sectors, and it's up to 12 months. So it's almost a year. And so you can kind of get ahead of those other job seekers, such that at least you can gain some work experience, and then also you have a foot in. A lot of things that very often we recommend to job seekers, if there is internships or short-term gigs, please go for it, because employers are more likely to recruit from people whom they are familiar with. So if once you get your foot in the door, even though it's not a full-time job, it's a short-term contract, just get in first, and hopefully you can prove yourself, and when it opens up, you'll be in a good position. All right. Next, I want to share a bit on the Skill Future Work Study Program. So actually, there's a lot of opportunities for you to continue studying beyond, let's say, what qualifications you have. I know most of you may already have like diploma, degree, and the panelists have also shared in terms of why do you get something else that complements what you do. These are also opportunities which you can go in, and there will be also opportunities for job matching for those, whether is it ITE, Poly, or even JC graduates. You can get up into one of these work study programs, even those with degrees. I think it doesn't hurt for you. For example, you have an engineering degree, but you have a certificate or a diploma in like data analytics statistics, and it also gives you a leg up in terms of having a wider range of skill sets, which will really help you moving ahead. All right. Sorry, I'm just going to rush through this because I think a lot of content is online, but I just need to raise awareness. There are these opportunities out there. Next is the PCP, Professional Conversion Programs. So for those who have some years of experience and find yourself in a situation where basically your job situation it's not good anymore, you are so-called, you feel that you are at risk, these are programs which are available. The three modes of PCPs are place and train, where basically they will hire you before they go for training, attach and train, work attachments, or even redeployment job redesign for those who are still working. So for this one, actually what happens is the government funds the company. So there's less reason for the company not to take you in, right? And it also gives a leeway, a runway for you to really try to go into new roles within the organization. What we see with job seekers, sometimes we just have to educate them for them to share with their employers. They say basically, boss, instead of firing me, there's a new role. Why don't you bring me on board? You can apply for PCP, to job redesign and so on, and also leverage on government funding. So this is what we share with some of our job seekers. Next is just some details for employers, which I don't think is relevant for most of you guys, but just telling you, they do get quite a lot of salary support, about 70%. Now it's 90% of monthly salary. So basically, the government really helps a lot in terms of funding the salary of people who go on PCPs. So this is something which you should be aware of, all right? Okay, next I just want to share a bit on skills framework. I'm not sure how many of you are familiar with skills framework, but this is an effort by the Skills Future Singapore to map out the industry transformation map. What I have here is the skills framework for the engineering services. There's another one for precision engineering. So what it means for someone who looks at it is, these are possible pathways that you can consider in terms of where you can see yourself progress, and then the courses needed for you to go ahead or to progress to the next level. So Skills Future Singapore has actually mapped out what courses you need at different stages, what skills you need. I'm sure there will be some changes with Industry Revolution 4.0, but the commitment is that Skills Future Singapore will review the framework every 2 years. So if there's new changes, there'll be updates, there'll be, so you are very much updated in terms of what's important for everyone, all right? Okay, pull it up. Oh, sorry. Okay. Okay. I don't know how many of you are above 25. Just to remind you guys, you do have money. Skills Future Credit 500. For those a bit older, you have a lot more. I think I qualify by October. I'll have 1,500 already. That explains my age a bit, right? But yes, so there is funding available. So a lot of courses are actually funded by the government. So this is actually the best time for you to learn. Honestly, because Sense is also a training provider, there are a lot more courses that's run online now. So what it means is, while you're sitting at home, you can basically finish 1 or 2 classes, even to have a full certificate just by going through your laptop and going for the tests and evaluations. Best way for you to build up your portfolio, best way to build up your skill sets. So I do hope that you can also look into using your Skills Future credit. You can just go to Skills Connect or My Skills Future, right? And the last point I want to share is, since apart from training, we also give support for job seekers, and this is our virtual brown bag series. I need to sell a bit of koyok here, because this is where we talk about. Sharael shared about your soft skills. I would say a bit on personal branding as well, a bit on new skill sets that you need to have. So we do promote workshops on LinkedIn, how to develop your personal brand. Talk about digital marketing, digital entrepreneurship, those type of skill sets. So if you want to find out more, because we have a whole range of courses, you can just come down, follow our social media pages, because we will update things quite frequently. All right, I think that's it. I think there's one more slide, but the slide doesn't seem to appear. Yeah, so these are the some programs that Mendaki Sense does. You spoke about data analytics. I just answered the question in the Q&A. Yes, Sense runs data analytics course, and it's quite cool because we also use, there's 2 courses that we run. One using Power BI, data analytics, and the other one, if I'm not wrong, it uses another platform. I can't remember it off the top of my head right now. But yeah, so data analytics is increasingly popular and increasingly important. So that's something which you all can consider. All right, and then over to the moderator, for Q&A. Thank you, everyone.
Thank you, Mr. Faiz, as well as thank you for the other panelists. We'll now move on to the Q&A segment. So can I invite all the panelists to switch on the camera? So I've shared the results of the poll, and we will answer the top few. So we'll answer the first one. Okay, so along with me is actually Mr. Amir Zakaria. He is a robotics trainer from Grace Robotics. So Amir, you want to say hi? Yeah, so he had also been answering the question, typing out the his answers to all those questions in the Q&A. So in case we run out of time, we would answer your questions by typing it out. Okay, so we'll answer the first one. PM Lee has mentioned that Singapore's economy has evolved differently as compared to 4 months ago. As such, the question is, how do engineers from mechanical, civil, and etc. continue to evolve to remain relevant to these changes? So maybe I'll get Prof. Aziz to answer first, and other panelists if you want to add on.
Okay, so maybe the way to answer this is I definitely agree with PMD here, because things will not be as what it was 4 months back. Okay, we have to re-look into the way we were doing things for the last 20 years. And you can see that over the years, the government has been pushing to move away from a labor-intensive economy to a knowledge-based economy. And just to take an example, since in 2018, for foreign workers or migrant workers, for every Singaporean you can basically hire 5 migrant workers. But today, for every Singapore workers you can only hire 3 migrant workers. So there's a signal there that we have to move away from a labor-intensive to a knowledge-based industry. So if I'm a mechanical engineer, if I'm a civil engineer, what does it mean to me? It means that whatever product I do today, I need to be able to think whether this product can be made in Vietnam, can be made in China, can be made in India, but the IP, the knowledge resides in Singapore, and the delivery model will change over the years. In the past, the entire manufacturing was done in Singapore, but the future may not be that kind of a model. I don't know whether I've answered the question. Maybe Sharael or will add on to what I've said.
So maybe I'll add on to that, and I completely echo with your sentiments, Prof. Aziz. I agree with PMD's statement that Singapore's economy post this COVID, it will fundamentally change in direction, or rather, it will have to transform, and we have to transform. So, as engineers, how does this then change our day-to-day role? I give you an example. This video conferencing, it's been a while. It's been around for quite a while, right? And just sharing a personal experience. When I was based in UK, running my teams in Canada, Germany, UK, and Singapore, video conferencing was a norm. But for us in Singapore, because the alternative, which is going up, rocking up, having coffee with another person, is so easily available, is there, that we take it for granted and we don't adopt these technologies until now during COVID. Another example, in the UK, the delivery mechanism for Amazon, you could have ordered anything from Amazon and on Amazon Prime. If it was anywhere in Europe with Amazon Prime, you could get the product from anywhere in Europe to you in UK in just one day, in 24 hours. For us in Singapore, we struggle with Lazada and all the other shopping sites that takes 5, 6, 7 days just to deliver a product to us in Singapore. So what I'm getting at is, what got us to where we're at right now may not necessarily be what would get us to the future. Having shops that is close proximity meant that we did not invest or we did not see a need to focus on digital sales or digital platform in order to sell. This is where I see that, in support of what PM Lee said, the economy will evolve very differently after this post-COVID as we tackle on this. And as us engineers, how do we remain relevant is to constantly evolve in that space also. What we do tomorrow should not be close to what we did yesterday. We need to figure out how do we do things differently. And Prof. Aziz is saying, it's about what is our value proposition as engineers to the wider network. It's about ideas being owned by us, but it could be made anywhere else. The whole idea of made in Singapore may not necessarily be made within the Singapore boundaries itself, but made with the Singapore identity or the Singapore ideas behind it. Right?
All right, thank you. I guess we'll move on to the second question, which is how do we incorporate elements of Industry 4.0 into our working environment? Prof. Aziz or Ms. Sharael want to answer this?
Okay, maybe I'll start and maybe Sharael can add in. So with regards to Industry 4.0, in fact, you can see today is a very good example. We are having a conference call and we are using some elements of Industry 4.0. Okay, so this is one example there. But what I find that in the working environment, you look in terms of 3D printing. Okay, how industry like the marine and offshore industry are using it. So in the past, we've definitely fabricated using welding when we bring two pieces of metal together. But today we are looking at the possibility that how basically we can do 3D printing of that particular structure. Now, what does that mean for Singaporeans? Today in the shipyard, if I want to get two pieces of metal printed, two pieces of metal welded, I use a foreign worker. But if in future, if I want to do 3D printing of the same structure, then I may use, if our Singapore engineers are trained, we can basically use Singapore engineers. So there's a value for us basically. So to me is that there are many elements there that we can basically incorporate in Industry 4.0 and try to see that how jobs in Singapore can be sustainable for Singaporean engineers.
Yep.
Sharael, I'll leave it to you.
Yeah, let me add on to that. I think to Prof. Aziz's point, it's about taking the small steps. Industry 4.0 may not be the big bang, especially in this current climate where capital and investment is restricted. I'm quite sure those of us in the industry, the first thing that has happened is culling on the capital expenditure projects for this year. So incorporating elements of Industry 4.0 need not go with a big bang. You could take it one step at a time. How? I'm sure everyone in his current job role right now has an Excel that he's using that is pretty much the lifeblood or the lifeline of the task that he does. And if you look to the next person beside you, she or he has another Excel that he or she is using, and you look to the right, the same thing. So you'll see that in your organization itself, you'll have many people trying to manage data through an Excel. Take Mr. Faiz's presentation just now. Look towards Microsoft Power BI, for example. As a team, see how you can then adopt Microsoft Power BI to pull all this data from 3 different Excels together, and how can you string it together as a value stream. Very simple, zero cost. You can get additional training funding for it also, but we can see how productivity can be improved in that space. So it doesn't need to be big. It doesn't need to be robots everywhere all around. And in fact, Mr. Amir Zakaria, he's a supporter for cheap robots, entry level, but work together with your team and see how we can incorporate those small elements. Take it one step at a time. Like I said earlier, be the lone nut. Start that movement going. And then as everyone see it moving, the movement will follow suit. So, Mr. Amir, maybe you want to add something to that?
Yep. Thanks, Prof. Aziz, and thanks, Sharael. Maybe something I'd like to add on is some automation can be easily implemented in some workplace environment. Something as simple as RPA, robotic process automation. It can help streamline your processes for administrative issues. It can do something as simple as let's say you got 1,000 name cards you got from a conference after networking, and then you just need some way to digitize them and send out an email to all of them. Something that you need to do, but it would take you maybe like a day just to do it. If something like RPA, you can look up. There are a lot of technologies in RPA like UiPath, Automation Anywhere, and these kind of technologies can help you do those kind of administrative issues from like maybe one day, 8-hour job, it can do it for you in an hour or even lesser. So like some of these small little things that can help improve your productivity are some of the easy steps for you to incorporate I 4.0 into your workplace. Yeah. So that's just some of the other things. Yeah. Would you like to add other things?
Can I just add one thing here? I mean, 1 week ago, you have seen there's a newspaper article on these robots, basically in shape of dogs. Basically, they were basically going around at the East Coast Park, more like your safe distancing ambassadors, basically. Now, these robots were basically made by Boston Robotics in MIT, basically. But recently, there was an interview by the CEO of Boston Robotics. And in fact, you can see that this technology that was adopted in Singapore, in fact, there are only few countries that adopted this technology, basically. And this is a very good showcase of trying to use robotics in an environment, in a co-ed environment, where basically you can see that whether people are adhering to the co-ed requirements, basically. So this is one example, a small example, but a working example, basically. How basically can use robotics in our daily life.
Okay, thank you for that, Prof. Aziz. That was a very interesting robot, indeed. And I myself working in race robotics, we got robots, and we see when Boston came in Singapore, we're like, okay, this is a big player coming in already. So, but it is good to have big names coming in, meaning that we are increasing our level of adoption in Industry 4.0. Yeah. Okay, next up, maybe we would want to go on to a bit of the Q&A. And one of the Q&A questions that was being is typed out here by Dr. Iril Seep, and it was directed to Sharael Taha. So the question is, with the advancement in technologies and Industry 4.0, we understand that change is the only constant. The question is, how do you manage the resistance to change within your organization? So how do you manage your organization resisting this change?
So I think change is the scariest thing for a lot of people. And with Industry 4.0, it's the same thing. Adopting change, because we don't know, we fear the uncertainty. Okay? I think especially when Industry 4.0 or changes is first branded as just purely robotics or automation. People see it as a loss of livelihood or loss of jobs, or getting out of a discomfort zone. I think what Amir shared last week was also important. It's about the messaging as you want to try to bring in this change. Industry 4.0 is first and foremost actually a change journey rather than the technical side of things. If you look at the technologies that's being used, it's usually not the latest and most cutting edge technology that gets most widely used, but rather it's the technologies that are able to assimilate together with the day-to-day working of everyone that gets most widely scalable. So the first thing to manage the resistance to change is the messaging, the conversations that you have. How is it first depicted? If you start it off with, "Ooh, this is robots, and this is we're going to lose, or rather we're going to change everyone here, and this whole shop floor will be robots," you'll get 0 buy-in factor immediately. So it's about the journey, and as I shared just now, it's about don't fear being the lone nut. Start the movement, and also for us as engineers now, it becomes more important on our soft skills. How do we bring people on this journey? How do we get them out of their state of fear? How do we get them to share their data? I'll share with you a personal experience as I was implementing the data lake in the organization that I was in. Right? So in the past, for those of us in the industry, in any production facility, you have your standard SQCDP: safety, quality, cost, delivery, and the people metrics. And in the past, it is always the data is always kept in silo. The safety guys would keep the safety data, quality guys keep quality data, engineering keeps its own engineering data, and operations keeps its own operation data. And they fear that sharing the data may expose them to them not doing the work properly, or not meeting the standard time that's required. So when we first implemented this data lake where everyone now have access to the data, everyone became fearful. They said, oh, this is proprietary data. No, I cannot share this engineering data. I cannot share this operation data. How long it takes to assemble this boat? Everyone became afraid. But that barrier was broken down when we start engaging people and getting the right message across on how this is being used. Don't use it as a stick, use it as a carrot to get the team together. And that's where your role as an engineer changes, is fundamentally different. I agree with Faiz, it's about the people. This revolution is going to be led by the changing mindset of the people adopting latest technologies rather than the other way around. It's not going to be about the technology forcing the people into that position. I hope that answers the question.
Thank you, Mr. Sharael. So,
if I can weigh in a bit on this, sorry.
Sure.
Yeah, I think industry revolution causes a lot of change in many things that we do, but we just have to realize that there are these three elements which I heard over a talk some time back. Three elements called high tech, high touch, and high trust, right? So for things which can be automated, you can use machines, you can use AI. There's a high tech stuff. So basically, it will definitely go towards the technology part of it. But things which are high touch and high trust, that's where the human aspect of it plays a big role. A case in point is, for example, doctors or people say that technology now can replace the role of doctors because they can detect what's your status. No, they can put devices to monitor your vital signs and everything. But so that's the high tech part of it. But do you want a machine to tell you what is your condition, or you rather hear it from a human being himself? So that's the part where the high touch and high trust comes in. So that's something which I always put in mind whenever I think about technology causing changes in terms of how we do. So that's why I'm kind of big on the Society 5.0, because that's where we can redefine what is it that we do. And even for engineers, I think you can redefine your value add in terms of, it's no longer about doing the basic sums and looking at Excel sheets anymore, but it's actually really the next level of integrating the different insights that you get from the different points of data, because that's something that machine still has yet to achieve in terms of how do you gather data pools, insights from the different perspectives and put the human element part of it. So that's my sharing lah. Right. Thank you.
Yes, that's true. With every of this industrial change, I mean, it will cause some changes. So the key thing is not to go on strike, to have the proper messaging, and like with a proper messaging, it's easier for you to collaborate with one another. All right, so we'll answer a few more questions here. One of these questions already been answered by Amir, because it's directed to the raise, attach, and train. So can I direct it to Mr. Faiz to just add on a little bit more, because you would like to know that if my current skills are based on cybersecurity, and I see that the potential way to augment that as security for robotic is a big concern. So maybe you can advise Dian if there is any courses or things that she can do to move from one cybersecurity into robotics. Yeah, Mikey.
All right. Okay. Okay. Great. So I would say that there are a lot of courses right now available in the market. I really need to understand basically what's your background and what is your needs really, because basically cybersecurity is still very big. I'll be honest with you, there's still a huge demand for cybersecurity, but if you augment it with robotics, then you'll be very unique, and that will be it'll be a unique proposition for you as an individual to go out and tell people, I do cybersecurity and I do robotics, and I can look at it in both perspectives. Right now in Singapore robotics side, I will need to look through in terms of which IHLs are doing it, but I'm sure that there are some polytechnics that are already looking in terms of robotics. For the university level, maybe I would guess Amir will have better response in terms of which are the platforms that you can go for. But my recommendation is try to look for the national agencies, the national institutes of higher learning, because they come with a lot of funding. So that's one way for you to try to mitigate the cost a bit on things, right?
Thanks, Mr. Faiz. I'll just add on a little bit to that question regarding cybersecurity and robotics. Cybersecurity, if you see the Industry 5, the pillars of Industry 4.0, cybersecurity makes up one part of it, and it will be an emerging technology that will be integral towards the future. So what I'm saying is, if you are a fresh grad doing cybersecurity, what would be very I would advise is for you to gain some experience in the field of cybersecurity before venturing into robotics, and then you can have the best of both worlds and mix and join the two skill set together and become that unique person that Mr. Faiz has mentioned earlier on. And in regards to robotics, there's like where I work myself, RACE is one of the places where we do teach hardware and software skills and everything under that is the umbrella for robotics. So we do have those courses, and you can also check out NTUC Learning Hub, and there's a lot of other companies out there as well that also has grants from SkillsFuture. So you don't have to per se get a structured formal degree. You can have short courses that you can upskill as well.
Thank you, Mr. Faiz and Mr. Amir. I guess there's always a way out, and there's always, I mean, you just have to explore. So we'll answer one last question before we wrap up the session. I'll pick this question. I see that a lot of Industry 4.0 improvement can come in during the product development or iteration stage. How does the process looks like in your personal experience? Does it involve having data scientists to gather data and analyze it with IoT and machine learning before communicating that to the designers of the products about their analysis and translate that to the engineers on the ground as well as executive management? So this is something similar that Mr. Sharael actually shared during his slide. Maybe we get Mr. Sharael, and if Prof. Aziz have anything to add on, you can add on.
Maybe Prof, you want to go ahead first on this one?
Yeah. So basically, as what I mentioned in my talk, that we should not have a silo mindset. With regards to data scientists, we always find that data scientists are IT trained. What I feel that from my experience today, the data scientist should be coupled with the engineer. The engineer is the best person to know what he wants and what should the outcome be, basically. So an engineer with the data analytics, data scientist background or learning will be able to come up with a product, with a better product. So if you design a product and then you leave it to the data scientist to basically give you data, to gather data, analyze it, it may not be the right kind of model, basically. So I'm currently working on an autonomous vessel. So my own experience. So what I basically told my team, let's find a data scientist to help us do the autonomous part of the vessel. We design the vessel, we design what we want to do with the vessel, and then we bring in a data scientist. We did interview a few data scientists, but what we found that they didn't understand our domain knowledge. By the time we educate them on our domain knowledge, it will take 2-3 years. By the time the project that we are doing, somebody else must have done it already. So what I told my engineer, that if you have the flair in terms of doing data analytics, why don't you go and learn? So what they did is that they went on to a Microsoft Academy, basically, and learn about BI, learn about AI. And within 4 months, okay, they were able to come up with solutions for us, friendly solution, but solution that works for the things that we are doing, basically. So to basically, what I'm trying to say is that today, there shouldn't be a silo mentality. Today, if you're a product designer, you basically learn, you need to get into the data scientist space, basically. Okay, yeah. Sharael, up to you if you want to add anything.
Yeah, I couldn't agree with you more, Prof. Aziz, on this one. So as Prof. Aziz was saying, we cannot have the silo mentality. It is about the value stream thinking. It is about the engineers trying to understand how that data is part of the bigger network. And I would like to share the same experience also as when we are transposing, we're developing our data lake in order to interpret what's happening in operations. When we first tried to approach it from, let's get a data scientist to do this, we realized that trying to share with them the domain expertise on how do you do repair for 18,000 parts on an aircraft engine would take years for the data scientists to try and figure it out. So again, we adopted the same thing like Prof. Aziz did. One of our engineers, or those that's more astute towards data, or that has more interest towards it, we trained him up in a period of, in fact, 2 to 4 months through Microsoft Power BI. They started developing our single source of truth, which is now our data lake that data is then pumped into this. I'll also, in this answer, I'll also answer Dr. Iril's question on garbage in, garbage out. And that's where, when you have an engineer looking at it, and you know what is it that you want to get out of this, and you are the one designing the thing for it, you can prevent the garbage from coming in so that garbage doesn't go out, right? So it's very important that for us engineers, picking up data analytics and having the problems being solved by domain expert who has the additional skill set, that is very much critical skill set, or the X factor that will define those that is in the engineering field over the next few years.
Couldn't agree more on the 2 points. I mean, none of us can work silo, right? And every one of us plays a key role in the entire system. I mean, if the data scientists give us a lot of data and they're all trash, but just collect the treasure that you want, then